In this video, we're going to walk through an example problem. We're going to try to design an electrolytic cell with manganese and tin. This will be basically the opposite of a voltaic cell, where we would have a spontaneous reaction that drives that electrical current. Here, we're going to need to apply a voltage to force the system to, to move current in the direction we want. So I pulled the half reactions for the reductions and their potentials for manganese and tin off of our standard reduction potential table. So manganese has a reduction potential of negative 0.1375, and tin has a reduction potential of negative 1.185. So just evaluating these two, if I was going to design a voltaic cell, I would say, oh, wow, that negative 1.85, that means the oxidation potential is positive 1.185. That's a large number. That would drive the spontaneous reaction, where the tin is oxidized. So we're going to do the opposite of that. We're going to make sure then that tin is reduced. So for our electrolytic cell, tin needs to be reduced. So reduction is going to take place at the cathode. So we're going to have our tin at the cathode and our tin plus 2 ions in solution. And that's going to drive the half reaction of tin plus 2 electrons, becoming tin, solid, which has that really negative potential for reduction. That's going to leave our manganese to be oxidized. So that's going to be on our anodes. We'll have manganese metal, and then we'll have manganese plus 2 in solution. And we're going to force these electrons to go the opposite direction that they want to in this cell. And the question is, like, how much voltage do we need to apply? Well, we're going to calculate the same way we would calculate anything else with our cell potential equation right here. And so we'll plug in our reduction potentials. We'll have our cell potential will be equal to our cathode's reduction potential. And so that's our tin. So that's the negative 1.185 volts. And we'll subtract from that the reduction potential of our anode, which is the negative 0.1375 volts. And when we add that all up, we're going to get a value that's negative 1.0475 volts, which is showing us that this is a not spontaneous reaction. But if we apply that voltage, we can make it happen.